Good morning. So in this lawn, we're restructuring the soil. There's a lot of areas still that are deplete. We're looking for superfoods for the soil. The cure and the constant are two different things. The reason I did not mow these seed pods today is largely they don't pass the flick test. So the seedlets did not fall. That means they're not quite ready. If I delivered that cellulose to the soil, the whole of the seed would be down regulating for growth because it would be bitter. Just like if I mowed this lawn at the bottom part of the plant, that would be the bitters. If you want more technical terms, look up allelopathic biochemical compounds. Now that's no-grow juice when it's negative. You don't want no-grow juice in the soil because then it makes the microbes lay down, and their function is to creating fertility. So when that seed pod, even though they're high and everything, passes the flick test and it drops its seed, that's when I know it's most viable. And it's actually got genetic markers where it's structured for exactly this shade pattern, exactly this precipitation and percolation topography. It's actually the perfect seed for this area. So when we get that down into a canopy where it can be entrained by the microbes, deholed and planted by the microbes, then we'll have more density, which therefore supports the soil, because the higher the density of a monocot, a plant that lives in the millimeter squared, that presents its canopy in the millimeter squared and taps from about a millimeter squared, is the most vested interest in creating fertility in that 1 millimeter. So what it does is it reflexively grows as to how much sun's coming through, and it gives off just the very top, the very yield portion, which is the sweet yield. When that gets down in, when there's a canopy for the soil microbes that can be metabolized. So then we can create this fertility that supports the density, and then we got an ecology that supports subspecies, keystone species, and life in general. So the key is, though, once this is ripened and flicking, is to catch it in the morning when there's turgency in the plant, water pressure, hydraulic pressure. That happens early morning, and it can happen a little later in the day if you've curated good density and then structured that cistern of water as slow release water that can be entrained in the soil once you have organics. So in the morning with the turgency, and if you look at the cylindrical structure of this stem, it's going to be able to lay over any direction. So you have to do some special tricks to mow it very tall, because if you're subtracting the canopy for the soil microbes, there's no point in putting down the seed. And so when you mow early, it has enough hydraulic pressure that stem won't just lay over and then fold back up after your process. If it does, change your pass route. So if you still have problems once it's matured and it's also popping back up when you're mowing very tall, then if you went this direction this time, the other grasses that got cut are going to lay left and right of that seed stalk. So if you came back the same direction, it has a clearance place to lay back down in the same rut. But if you came at a 90 degree, it's going to put the stem against those laying blades of grass. So if you come at a 90 degree of the original pass, then 9 times out of 10, you'll be able to get that seed stalk, get the seed into the soil, and then you'll be in a position to get the density that you wanted. All right, you have a good day.